Okay guys, so let's continue looking at trigonometry. Yesterday, I think in our previous videos, we looked at the Pythagoras theorem and how that helps us find lengths of a given right angled triangle. So today I want us to continue looking at some other methods that we can use to find the lengths and the angles inside. So today, for the good of this video, I want to use this angle here, theta, as my reference angle, which means even the notation for this triangle would change. So in the previous videos, we established that the side that is opposite the right angled triangle is called the hypotenuse, and I'll just call it H to mean the hypotenuse, and then the angle, the side that is opposite the theta, which in this case is this angle here, would be the opposite, which I'm just going to call O. And then this side here, which is close or next to the angle, is called the adjacent. I'll just call it A. Now, if you are not using the Pythagoras theorem, there is another method that is streetwise known as the SOHCAHTOA. Now, I'm not going to go into that, but I just want to give you a heads up. There's a relationship between this angle and all these three sides here, all right? And those relationships that exist, they are called sine, cosine, and the tangent, depending on what sides you are using. So in short, we'll be looking at three different types of trigonometric ratios that we can use to find either one or two of the sides, all right? So for example, what I know is there is the sine ratio, there is the cosine, and there is the tangent. Right? So all these ratios, we'll look at them in particular. They relate this theta to the sides that we've got here. All right? So this angle here, in one way or the other, will be related to all the three sides outside the triangle. Now, how do we find sine? All right? So there is what we call sine theta, all right? The sine of this theta here would always be equal to the opposite side, the length of the opposite, which I'm just going to call O, over the hypotenuse, which is the longest side. Okay, so this is just the introduction to this trigonometric ratio. So it means if you divide the opposite side by the hypotenuse, these two, you get a ratio that we call sine theta. This is with reference to this angle here. So it is as good as if you get your calculator nicely. If you look at your calculator, you'd find that your calculator has got something nice. In the third row, you'd find that it's got something like the sine, the cos, and the tan. So those three things are the trigonometric ratios. So if you do sine of any angle, it is as good as doing the opposite and over the hypotenuse of the given triangle. It will still give you the same answer. But I don't want you to worry much about this. I'm just introducing these, and we'll do examples and see how these work nicely. Then cosine, okay, cosine theta, sometimes known as shortly written as cos theta, is always equal to the adjacent divided by the hypotenuse. So cos theta is when you divide, you get the trigonometric ratio called cos theta when you divide the length of the adjacent by the hypotenuse. Right? Then there's the last one here, which we call the tangent. Now the tangent, all right, the tangent, which is the trigonometric ratio, is always found by dividing the opposite over the hypotenuse. So you can see that these three trigonometric ratios, they differ by what you divide and what ratio you are dealing with. So I just want to do this. For the sine, if you look at this sine theta, if we get the S, we put it there, and we get the O, we put it there, and then the H. So that this means we are saying sine theta is always equal to opposite divided by the hypotenuse. If we get the cosine, we are going to say C and then we get the a, we make that short vowel and the h. It means that the cosine, the trigonometric ratio cosine, is the same as adjacent over hypotenuse. And if we get the tangent, we write t. It is as good as saying it's the opposite divided by the adjacent. So if you look at this, this is what people say SOHCAHTOA, so that people can use this to remember the formula for these different trigonometric ratios. So it's like if I ask you to say, given this triangle, in this case, let me just put numbers there for easy explanations. For example, let's say I've given you these nice triangles here. Let's say we've got a 3, can I use a 4 there, and a 3 there, and I ask you to say find, so guys, sorry, just give me this nice short time here to get rid of this. Okay, so let's say, for example, what we've got is this nice triangle here, and we've got this theta. Then the question comes and says find the value, find sine theta. All right, now this sine theta is a ratio of two sides, so you need to remember, using this so-called SOHCAHTOA, to say, to find the trigonometric value of sine theta, we say opposite over the hypotenuse. So that's why we say so. That means you are saying the opposite divided by the hypotenuse, and then all you do is get the opposite. What's the opposite in this case? We are using this angle, so the opposite to this angle is 4. We are going to say 4 over, what's the opposite for, what's the hypotenuse in this case, which is the longest side, is going to be 5. So our value for sine theta, all right, would be equal to 4 divided by 5, which I know you can get. 4 divided by 5 is given as 0.8. So it means the value of sine theta is 0.8, right? And then if the question was saying find the value of cos theta, if you've forgotten the sides and everything, just remember this so famous thing called SOHCAHTOA. So it means you are looking at C, implying that you divide A by H. So our adjacent in this case is 3, so you are going to say 3 divided by 5 to give you the value of cos theta to be equal to 0.6. The same is the case if we ask you to say find the value of tan theta. You just need to come here, all right, and say tan theta is always opposite divided by the adjacent. Our opposite to this angle is 4, so you're going to say 4 divided by 3. Then whatever value you are going to get there, which is about 1.3 recurring. So this is the value of the tan of theta. So guys, this is not like the actual video, it's the introduction to these 3 trigonometric ratios, which are very, very important. But one thing in my conclusion that I want to make clear to you is that SOHCAHTOA, which is written as this in some books, this famous so-called SOHCAHTOA, is used to find the relationship between that angle and the two sides. All right, it could be the two sides, any of the two sides that we've got. So it is important that you remember one thing, that SOHCAHTOA means sine theta equals to opposite over hypotenuse. Cos theta means adjacent over hypotenuse, and then tan theta, okay, means opposite over adjacent. So thank you very much guys for taking your time. This is just the introduction. The next video talks about these trigonometric ratios in detail, and please take time to watch it. I was just trying to introduce these things and it took a bit of some time, but thank you very much for your patience, and please watch out for the video that comes with more examples on trigonometric ratios, in particular sine, cosine, and the tangent. Thank you.